Hello, hello. Can you hear me? Right. I guess yes. So thank you for introduction. Hi, everyone. Let's start. So today we'll talk about change detection, and we'll be digging into how it affects performance and why signals are a big deal in a world of change detection. But before we begin, let me introduce you to Ralph. Ralph is a guy who fixes cars, and he's going to give us a little bit different perspective and show how change detection works in the context of his service station. So let me quickly tell you a little story about Ralph. Once I had a minor issue with my car, and when engine lights came on, and I couldn't really figure it out what was wrong. So I took my car to Ralph's workshop to get it fixed. And he told me that he needed to run a full diagnostic check to find the problem, which sounds reasonable to me. However, he surprised me a bit as he announced that he checked every single component of my car, even parts that were clearly unrelated to the engine light issue. And after a long wait and hefty bill, he found it was just a last gas cap. So causing that small issue causing these lights to come on. So as you can see, sometimes a small issues can lead us to an exhaustive process if not handled with precision. And speaking of unexpected outcomes, let's shift gears and talk about change detection. But before we'll do that, let me quickly introduce myself. My name is Jarek. I'm from Poland. My journey with Angular began in its early days from version 1.0. I'm a lead architect at the Finland, also co-host the Angular Catch-up podcast. And by the way, I invite everyone to follow along. You can find me on Twitter as well as on LinkedIn. That's all about me. Now, where were we? Yes, the old school change detection. So in the beginning, most of us use the default change detection, right? And similar to Ralph's approach, who checked every single part in my car, the default change detection triggers unnecessarily checks and updates throughout the entire application. So it relies on a flag that is called check always, which essentially tells Angular, hey, check everything regardless of whether any change occurred or not. And you might say, yeah, sure, it works, but it's a little bit of overkill, right? And definitely slow things down. So let me show you the default change detection in action and explain why it generates so much noise using an example app I've prepared. So this is the application that highlights the 3 nodes component and executes the animation whether a change detection ran in a node. At the top, we have a bunch of buttons that allow us to mess within the components' tree depths as well as background colors of the nodes. So each node comes with a pair of buttons, the manual change and set interval change, and they trigger change detection with and without signals respectively. So as we can see, with the default change detection, Angular keeps an eye on all components. Regardless of the component we clicked, Angular ran change detection for the entire component tree. So why is that? Well, let's try to find the answer in the Angular source code on a GitHub. So I did mention earlier that the default change detection relies on the check always flag, which is checked here in the detect changes in view method, which is part of change detection TypeScript file. And this detect changes in view method defines a certain different criteria for checking components, inspecting their flags associated with the view and its modes. So whenever this check always flag is set to true, it calls a refresh view method, which essentially refresh not only the current view, but this refresh view method calls detect changes in child components method within this global flag, which when we'll get back to this detect changes in view method, combining with check always flag marks this should refresh flag to true and calls refresh view again. So it's kind of like a domino effect, right? Making sure the entire component tree gets updated whatever happens. The question is, can Angular do better? Of course. Angular introduced the OnPush change detection that makes things faster. However, to enable it, developers needed to notify their components that they want to use this strategy. And OnPush strategy updates components when an input reference changes. We mark component for check using mark for check component, or any asynchronous event happened, like XHR request that could be handled by an async pipe, for example. Overall, by focusing on what's changed instead of constantly checking everything, OnPush makes things faster, more efficient, and, well, who knows, maybe prevent us potential disasters. So OnPush is like Ralph, the mechanic I did mention, who's knowing exactly where to look in my engine light issue, and only checking the related car components and dependent parts, but nothing else, right? Saving both times and money. How does the OnPush change detection strategy works? I did mention that this strategy gets triggered when we do things like setting a new input value in a child component. So let's get back to the Angular source code and verify the part that is run when we set a new input. So when we set a new input, the setInput method is called. And at the beginning, it just verifies that the new value of the input is different than the previous one. Once it confirms that, it marks this component view as dirty with markViewDirty method, which basically tells Angular, hey, this child component view needs updating, so take a look next time you check for changes, right? And the same idea applies when, for example, we are using an async pipe. So when we are using an async pipe, it subscribes to an observable and update the value. And it updates this value by calling markForCheck method, which in turn triggers markForDirty method. So the markForCheck is also used in a few other scenarios. I don't want to walk through the source code of those scenarios. I will just leave those scenarios. So for example, we can initiate the change detection manually using markForCheck. We handle the DOM event or attaching the view. But what is really common is that in all these scenarios, at some point, we call markViewDirty method. So let's take a look a little bit closer to this method. We can see it's a little bit like a domino effect, right? It starts from a specific view here and moves up the family tree by checking if there's a parent, marking each view along the path as dirty, which means they all need checking. And when it's time to do this actual checking, Angular looks at this view marked dirty. So if he'll find the component that is marked as a dirty, it means this component needs to be re-rendered. And we refresh the view by calling again refresh view method. So let's check how OnPush works in our application. But before we'll do that, let me change the change detection strategy in our application. All right. So now when we click on manual change button, we can see that application react in a little bit different than before, right? The click triggers an event for this click component itself, as well as all its parent components. So this is exactly what we should expect, because as I said, we mark all these click component ancestors as dirty in the markViewDirty method. And this is really huge performance improvement compared to what we've seen in the default change detection. The question is, can Angular step up this game? You bet it can. So since version 16, Angular has been introducing some fancy new features like these things called signals. And I said these things on purpose because I didn't really understand what signal is. And it's just a wrapper around the value that can notify interested consumers that this value has changed. It can contain different values from simple primitives to very complex data structure, and we can read that value through a getter function, which allows Angular to track where the signal is used. Now, the cool part is Angular allows us to utilize the signal power and combine it with this on-push change detection strategy to mark certain components for updates. And this little trick eliminates the needs for unnecessary check, whether they are parent or child elements. So let's see what makes signals work the way they do. So whenever we tweak a signal within the component template using methods like set or an update, it's like a little chain reaction. So first, Angular calls signal set function, which send out the notification here to all live consumers waiting in a view, making it go, hey, I'm dirty, right? And this consumer mark dirty method calls mark ancestors for traversal, which mark all the clicked component ancestors right up to the root with the flag called has child views to refresh, indicating, hey, I've got some child views here that needed to be refreshed. And if we'll take a look closer to this mark ancestors for traversal method, it's very pretty similar to the mark vdirty method I've spoken. The difference is that instead of marking all parents by a dirty method, it marks all ancestors by has child views to refresh flag. So let's back into our detect changes in view method. So here is a really clever part, right? So whenever the component is marked with this has child views to refresh flag, there is no need to call refresh view. Instead, it skips right ahead checking out the child component if there's any. And this smart shortcut helps Angular to avoid wasting time of unnecessary stuff, ensuring smooth and efficient operation. So let me illustrate that using, again, our application. Once again, when I click on manual change button, we can see that change detection is fired for the click component itself as well as all his parents. However, when we update the signal inside the set interval method, we can see that only one component actually gets refreshed. Pretty cool, huh? So let me get back to the presentation. It's like giving our Ralph mechanic a high-tech diagnostic gadget that can identify the problem spot on, like without really any guesswork. And he wouldn't really need to manually check each component, but could rely on precise signals to guide him. So it's like combining on-push strategy with signals Angular. You can do more efficient and targeted change detection. So hopefully I've answered why signals matter when it comes to the change detection. On-push within signals is like a sniper shot for detect changes. So it allows us to specify which component should be rendered when certain signals change. And this means instead of refreshing the entire component tree or a single branch when we use the on-push change detection, we will render only the component directly affected by the signal change. That's all I've got for today. Thank you for attention and listening. Hope you enjoy it. You can grab the code of the application I've used by scanning this QR code. Thank you very much.
Yeah. Hey, thanks for all the core memes and this talk. That was very nice. Also, I realized that basically, I'm not sure why we call it second track, because we could have just called it the signals track at this point. We have so much talks about it. It's quite
Yeah,
crazy.
I did share some ideas how we can adjust the names in a little bit better way, because
Yeah.
like, let's take a look for the default change detection. In my opinion, it should be called check always, because this is the result of the default change detection. But yeah, like, probably Angular will tweak some different names and work on that more and more. What we can see, it's going really on a very more and more efficient way when it comes to detect changes, which is very good, right?
Yeah, indeed. Perfect. Thanks again, Jaroslav.
Yeah,
Sorry if I said Jaroslav, but thanks
it's
again for this talk.
yeah, you can call Jarek, so we have
Okay.
short and more official way. Thank you for having me, and thank you really once for the invitation. Take
You're
care
welcome.
and
Thanks
see
for
you.
coming.